how the heck do we come up with an equation of a rational? Now, what I would like you to do before we even do any of this is I want you to type this into your calculator. So you're going to type in y equals x plus 3 over x minus 1. X plus 3 over x minus 1. We're just looking and we're trying to figure some stuff out. X plus 3 over x minus 1. We're just doing a little discovery. You don't have to write anything, nothing. We're just discovering stuff here. So I told you when it was just a basic rational, correct? And there was no point to discontinuity, we could use transformed form. We could put the vertical asymptote in where in the bottom. The horizontal asymptote was plus at the back, and we solved for A. We agree? But when we have points of discontinuity, we can't do that anymore. We have to come up with a different way. Okay? So when you type that into your calculator, press graph.
There we go, got it.
Okay. What is the x-intercept on your calculator? What does it look like it's at? Did you type in x plus 3 or the x-intercept? Where is it crossing the x-axis at? -3, right? Okay. Type this one in. So this one you said the x-intercept's at -3, 0. We agree? Okay, now type this one in. I'm going to give you the factor form. X plus 3, x minus 2 over x plus, or x minus 1, x minus 2. So type that one in.
Just by a guess. Just by a guess, I think.
He's right. It cancels out, so it's not the what. Where's my x-intercept at? -3. What's at 2? A point of discontinuity, so not my x-intercept. Do we agree? Everyone see that? Where is my, so this is what you guys are saying. Let's pay attention. You don't have to write this down. I'm just showing something. We're going to write something down in a second. So what you're telling me is this is the point of discontinuity. You agree? Because it crossed off. So at 2, I have a point of discontinuity. 2 and something. How do I find something? I plug it back in for my y into the simplified equation, and I would get my y with point of discontinuity. This is always my what? What does that help me get? The one that doesn't cancel off. My x-intercept. So if I go x plus 3 equals 0, I'm going to get x equals -3, aren't I? Now why? Why would that be my x-intercept? Well, I'm going to go on a separate sheet of paper here. I have y equals x plus 3, x minus 2, x minus 1, x minus 2, right? We know because of a point of discontinuity that crossed off, right? So we know we're left with this. Y equals x plus 3, x minus 1. How do I find x-intercepts? What should I always think when I think x-intercept? What equals 0? Y. So I could go 0 equals x plus 3 over x minus 1. And then I can multiply the x minus 1 up. And what happens to it? Multiplied by 0. It goes away, correct? And then I solve it out. X plus 3 equals 0. X equals -3. So that's why the factor that's always left on the top ends up being the reverse, the factor of your x-intercept. Right? The factor of your x-intercept. Does that make sense? So, note to self, when we did this before, so you're just paying attention because we're just reviewing some stuff here. So if I had just given you this, and that's a 9. This is a basic rational function, right? Are there any points of discontinuity on this bad boy? No. So when there's no points of discontinuity, can I just fill it into transformed form? Yep. We did this before. Transformed form was y equals a, right, over x minus p plus q, or x minus h plus k. It doesn't really matter. What do I put down here? My vertical asymptote, correct? My vertical asymptote is at x equals 2. So what's this one going to be at? X minus 2. And then my vertical asymptote comes back here. Oh, sorry, not vertical. Horizontal. This is the vertical. It's going to be at plus 3, correct? And then what do I have to do after that? We did this in the lesson. You have to fill in your y-intercept, or a point that's bolded, correct? The only thing you don't fill in is your x-intercept. So, my y-intercept is at 0, 9. That's my x and my y. So I'm going to go 9 equals a 0 minus 2 plus 3. Subtract my 3, I get 6 equals a over negative 2. Multiply by negative 2. And my a is negative 12. And I'm not done, because that's just my a. So y would equal negative 12 over x minus 2 plus 3. We agree? Does it make sense that a is negative? What quadrants is it in? Technically, if this was quadrants, 2 and 4, that's where it's negative at, right? And then 1 and 3 is where a is positive, so it does make sense. So these were the ones we did before. The ones where it was a basic rational and I had to come up with an equation. We agree? Then yesterday we ruined it because we added points of discontinuity. Destroyed the whole thing. Okay? So, that's how to determine an equation when there isn't a point of discontinuity. Now this is what you want to write down. So an equation of a rational with a point of discontinuity. Now, how do we set it up? Well, we're going to go y equals, and we're going to have a full fraction, right? That's what we did yesterday. What do we always have to look for in the end every single time we did a polynomial, or even last one? We have to solve for a every single time, because a is our vertical stretch, and it's actually not going to affect any of the other things. So we do have to have an a in front. What else did we just say was up here? Your x-intercept. It's in factored form, but your x-intercept is up there, correct? What else would be on the top and the bottom, if you had it, if it existed? Yeah, a P of D, I'm going to write it as. You can't write this as short form on a test. You have to write point of discontinuity, but I'm going to do this. So if there's a point of discontinuity, it's going to be on both, correct? And then what was the other thing on the bottom? Yeah, your vertical asymptote. What if there is no vertical asymptote? I just don't put that bracket, right? That's all there is. Because remember, sometimes you have a point of discontinuity and the bottom goes away. It's a straight line with an open dot. You just wouldn't have a vertical asymptote. If you memorize that, you can do every single one of these questions. And if you, instead of memorizing it, you understand it, you won't make mistakes on it. So you understand why? Points of discontinuity, remember? We get the factor of those. It's going to be on the top and the bottom, because that's when we know it's a point of discontinuity. It cancels off, correct? We also know when it's left behind, it's a vertical asymptote. And we just proved that what's up top that doesn't cancel off is always our factor of our x-intercept, correct? So that's why it's x-intercept, point of discontinuity, vertical asymptote. Now, what if there is no point of discontinuity? You could just omit this and do that last question in this format as well, right? X-intercept, you just need the x-intercept. Okay? All right, we're going to go back to the textbook part. So you're going to write this down because it's part of your homework. We're just doing it together. We're like homeworking. We're homeworking, networking ability. So we're doing number, whatever that is. I don't know, it's really smudgy. Is that 7? What is that? I don't know, I didn't take the numbers, it seems. What number is this? 7? Okay, so it's in the homework number 7. It's going to be for homework. So we need to write an equation of what's below. How do we set it up? Is there a point of discontinuity on this one?
Yes.
Yes, so that's the first thing you have to look for. Most people forget to look for it, like they miss the little dot. See there's an open dot here? Yeah. So we're going to get y equals a. What comes next always? X intercept. My x intercept is at x equals -6. So what's it going to be as my factor? X plus 6. Then what comes next? Your P of D, and this one everyone's going to screw up always. Because it's easier. So when it's on the y-axis, what is my actual x value? It's x equals 0. And then people are thrown off. If I gave you like x equals 75, you'd be like, x minus 75, no big deal. I give you x equals 0, you're like, I have no idea what to do. X equals 0 is the root, or is like the actual number, right? And x equals 0 is also the factor, because it's equal to 0. So, what am I going to put in these brackets? Just an x. So when your x equals 0, it's the only one where you don't have to work backwards. Could I go x minus 0 if I really wanted to? Sure. You're never going to see it in the answer key, but it wouldn't be wrong. Now, if your point of discontinuity was at x equals 3, let's say, we would put in x minus 3, correct? If it was at x equals 7, we'd put in x minus 7. If it was at x equals -9, we'd put in x plus 9, correct? This one is the only one, it's on the y-axis, so it's at x equals 0, which factor is x. So don't let it throw you off. That's the one that people, it's too simple almost that you guys don't know what to do with it. Okay, we're missing something on the bottom. Your vertical asymptote. My vertical asymptote is at x equals. Am I allowed to write VA on a test and assume that I know what you're standing for? You're absolutely not allowed to. There is no short form allowed on your test, and if you do it on the diploma, they will not give you a mark, because then you're assuming that they know. That it has to, if you're using short form, it has to be in the actual math textbook as that. It is not, because that is your approved resource. So if you want vertical asymptote, it would have to be at the actual question, because the reason why you'd have to have the legend at the question is that a different group of people are marking the first written response, the second written response, and the third, and you're not allowed to look anywhere through the test to look at anything else. So if you say at the very, and this, it's an asked question, if you said at the very top of your test in the multiple choice section, which we never are allowed to look at, and they're stuck together with like a sticker, so I'm not actually even allowed, I'd have to rip the sticker, which I'm never going to do. If you put the legend up there and said VA represents vertical asymptote, I can't see it. I'm on question 2. I don't know. And a different group of people get trained for question 1, part AB. Different group of people get trained for question 2, AB. 3, AB. So if you're ever using a legend, which some people do, you have to make sure you have it on that page, because we're not allowed to flip around.
So what you're saying is I need to photocopy 3 pages with legends on them and staple them to mine.
There's no such thing. Okay.
Why not?
You can't bring photocopied anything.
Not even the legend?
No.
It's my own legend. It's not you.
You're killing me. You guys are just like, this is like laziness at its finest. That's what this is. Okay. So my vertical asymptote is at x equals -2. So what do I have to put in there? X plus 2. And then people say I'm done, because most often people will forget to put the a value. But we're not going to, because we forget. Sometimes the a value is 1 and you luck up. Sometimes it's not. How do I get the a value now? You plug in a coordinate. So, you can, what we're going to have to do is actually cancel off the point of discontinuity, right? They're not going to like go away for life. You're bringing them back. But whatever we put here, if it was a 3 and a 3, they just cancel anyways, right? So we can, if we have a point of discontinuity, we can actually use the point of discontinuity to solve for a. You know that? Because if I cross this off, is my point of discontinuity there anymore? No. So can I not just use 0 and 3 now? to solve for A? Yeah. Because remember, you would normally take the 0, the x to the point of discontinuity after it's canceled off, you could solve for the y. Or the y and you could solve for the x. So you can actually use the point of discontinuity if you cross off those factors to solve for A. So let's do it. So we're going to get y, which is not y. We're going to get 3 equals A, 0 plus 6 over 0 plus 2. So 3 equals 6 over 2, which is 3A. Divide by 3, A equals 1. We would have lucked out anyways. So we have y equals 1, x plus 6 times x over x plus 2 times x. What could they do if they didn't want to leave it in this form? They could just distribute it, right? And then look for that multiple choice answer. So as long as we cancel off those points of discontinuity factors, we can solve for A using the point of discontinuity, but when we come back to put back in the equation, we need to still list those x's. Okay? Go. Try this one. This point of discontinuity is at -3 and 2.5. Just so you know. So number 8 is the exact same as what we just did, except instead of a graph, they're just giving it to us in words. Okay? Number 8 is the exact same as what we just did, except they just gave us words. So we're going to go down to B. Don't worry about A. We're going to do B. B says a vertical asymptote at x equals -4, a point of discontinuity, oh my gosh, can't speak, at -11 over 2 and 9, and an x-intercept of 8. So I gave you all the information you need. The catch here is the point of discontinuity at -11 and 11 over 2. You guys will give me the factors x plus 11 over 2, and that's not the answer they'll ever have. It's not incorrect, it's just not going to be there. So what you have to remember, and I did this in polynomials with you guys, I'm just going to go to a separate sheet just for a second here. If I have my point of discontinuity is x equals -11 over 11 over 2, you could go x plus 11 over 2 equals 0, but that's a really wonky factor around the top and the bottom, correct? So never going to write it like that. They're going to work it back to how you just solved for it. So remember, if you had, for example, 3x minus 2, you would go 3x equals 2, you'd add it over, and then you divide by 3, and you'd get x equals 2/3. That's how you got the fraction, right? So you didn't just go, it wasn't x minus 2/3 and you moved it over. So you guys are really good going this way, and then going back, you're like, x minus 2/3. I'm like, that's not how you solved it in the first place, so how do you just miraculously give me that? How did you do it? You added or subtracted first, then divided, correct? So now you're just going to work your way backwards. If you have x equals -11 over 2, instead of adding and subtracting and then dividing, you're actually going to do what first? Multiply the 2 up and then add. Because that's what you did to get here. You have to undo it to get back. So we get 2x equals -11. 2x plus 11 equals 0. So that's actually the factor for your point of discontinuity. Does that make sense? Okay. So I'm just going to do the question over here. You're going to give me the information again because I don't remember what it is. So we have y equals a. We're going to need an x-intercept. We have our point of discontinuity is 2x plus 11. And it's going to be on the top and the bottom. Then they give me the x-intercept. What was the x-intercept at? What does it say in the book for B? It's at 8. So if my x-intercept is at 8, then you're right. This will be x minus 8. What does the bottom one get filled in with? Your vertical asymptote. And what did they say? Where's that? Sorry?
X equals -4.
X equals -4, so what's going to go back in? And the moment if I don't have a point of discontinuity, I need to go find a point off the graph to use, correct? If I have a point of discontinuity, I can just cross that off and use it. Why not? Okay? So my point of discontinuity was at negative 11 over 2 and 9 or something? I don't know, what was it? What was it? Was it 9? I'm just randomly guessing. Okay. So that's my x and my y to solve for my a. So I'm going to pretend those go away. I'm going to erase this because it's absolutely nothing to do with this question. No, I'm not. And I'm going to plug in, not so nice, negative 11 over 2. That's okay. So I'm going to get y equals a negative 11 over 2 minus 8 over negative 11 over 2 plus 4. And my y was a 9. I don't know why I didn't fill it. I want you guys to try and solve it out. Use your calculators, use your brains. See if you can get it. And then so we're going to get 9 equals a, and then we're going to negative 16 over 2 minus 11 over 2 is negative 27 over 2. And then this is going to be 8 over 2 minus 11 over 2, negative 3 over 2. Oh, it's going to end up being 1 again.
Yeah.
Negative 27 over 2 divided by negative 3 over 2 is negative 27 over 2 times 2 over 3. So the 2's are going to cancel and you get a 9. I promise you your A isn't always 1. These are just happening to work out nicely. But sometimes they are. And then we're going to expand it to match the back. So we're going to get x times 2x is 2x squared. Plus 11x minus 16x is minus 5x minus 88 over 2x squared. Plus 11 plus 8 is plus 19x plus 44. You guys are working on C by yourselves. Try C.